lesson 72. Factors that are sums and pyramids and cones, okay? So this first one's a factoring problem. So go ahead and write that down. It's kind of weird looking. All right, we have a plus b in parentheses x squared plus 8x, and then in parentheses a plus b plus 15, and then in parentheses a plus b. So the first thing we always do is factor out a GCF. And the weird thing about this is what's common is actually a binomial, right? There's like a sum that's common. So every single one of these has an a plus b, okay? So the a plus b gets factored to the front. So that comes out, and it's like it all leaves as one, just like when you take out a common m, or whatever you're taking out that's common, it just goes in the front, okay? So what's left after I put this in front is an x squared plus an 8x plus a 15. So again, that a plus b just gets written one time in the front because that's the GCF. Then you see if you can factor tractor what is left over. So everyone, what multiplies to 15 and adds to 8? Yep, so we leave the a plus b here. And then this is our two sets of parentheses, x and x. And we've got to do plus 5 plus 3 or plus 3 plus 5. Okay, multiplies to 15, adds to 8. All right. Let's try one more. Okay, so we've got a sum or a binomial that's common, the m minus the b, but there is something else that's common that we want to factor out first. What else is common, everyone? A c, good. So I actually want to take out an m minus b and a c because every single one of these has a c. Now, we usually put the c in the front, okay? Monomials go in front of binomials. So put the singleton in the front, all right? So again, this and this factored out, okay? What's left now is an x squared, all right? And then same, the m minus b and the c factored out. So I have a minus 2x left. And the m minus b and the c factored out, and then I have a minus 24. So I keep my c, m minus b, and then I want to factor that trinomial that's left over. So what multiplies to negative 24 and adds to negative 2? Negative 6 and positive 4. Good job. Okay, those add to negative 2, multiply to negative 24. All right, now switch it up. Okay, volume of a pyramid, surface area of a pyramid, volume of a cone, and surface area of a cone we're going to do today. All right, so volume of a pyramid is 1/3 area of the base times the height. In other words, if this had been a prism, okay, the difference between a pyramid and a prism is that a prism would have a rectangle here and a rectangle on the top. So it would have the same base, top, and bottom, okay? This all meets up at a point, so it's a pyramid, and it's 1/3 the volume of what it would have been if it had two faces that were rectangles, okay? If it had been a whole prism with a square and a square, all right? But since it all meets up at a point, it's 1/3 of it, all right? So volume is equal to 1/3 area of the base. So the base is this lovely rectangle, so what should I plug in for area of the base? Yep. Okay, 8 times 10 for area of that rectangle. And then we multiply by the height. Now, the height cannot be a slant height. So if they gave you, like, let's say this leg was 13 right here, don't pick the slant height. Notice that this height makes a right angle with the base. That's the height you have to pick. All right, so I have to plug in 12. And then we want to evaluate, so the 3 can divide into any of those numbers. Because there's no plus signs, it's all being multiplied, you can pick which one it divides into the best, and that would be the 12, all right? So 3 goes into 12 4 times, and you just plug it in, or just divide it at one time. So now I have 10 times 8 is 80, times 4 is 320, and this is centimeters, and volume is always cubed, all right? The main thing is the 1/3. Okay, pyramids, 1/3. All right, let's skip that. We don't have a lot of time. All right, surface area of a pyramid. This formula, I feel like you maybe did at the very end of pre-algebra, like the last like week or two of pre-algebra. All right, so this is one you're gonna have to maybe study before the test. If I tell you it's on it, you might wanna look back at this formula. All right, surface area of a pyramid is area of the base plus perimeter of the base times L. And you're like, what is L? All right, it's super important to know what this L is. You probably need to write it down. It is the slant height divided by 2. Okay, let's go ahead and do the entire surface area first of this pyramid. So surface area is equal to area of the base. All right, my drawing is not very good. That is a square, okay? It is a square. So what should I put for area of the base? 10 times 10. All right, so this square right here is the base, and it's a square. The picture in the book will be better, all right? 10 times 10 for area of the base. Plus, okay, now I need perimeter of the base. So perimeter of the base is what? Yep, 10 plus 10 plus 10 plus 10, all right? So the perimeter is 40. Then we multiply by the slant height, which they gave us, all right? The slant height is actually the height of this lateral triangle. So see this triangle right here that I'm crossing out really nicely so you can't see it? There you go. All right, so I'm going to go like this. This is the height of that side, okay? That's what you're looking for. So I'm going to plug in the 12 for the slant height, and then I'm going to divide by 2. All right, so 10 times 10 is 100. Again, the 2 you can divide into either one of these. I'm going to do the 2 into the 40, which is 20. Then I'm going to do 20 times 12, which is 240. Add these together to get 340. Sorry, ran out of room here. All right, 340. And this, let's pretend like these are centimeters. All right, and this would be squared because it's surface area. All right, so surface area is always units squared. All right, what if they ask for lateral surface area? All right, lateral surface area is everything but the base. So all it is are the triangles around the sides, okay? So if they ask for lateral surface area, LSA, it's everything except this. So it's just PBL divided by 2. Perimeter of the base times the slant height divided by 2. That's really just adding up those triangles on the outside. So again, perimeter of the base is 40, slant height is 12, and divide by 2, which just gives you this piece here, the 240. It is still units squared. Okay? Yeah.
Are there going to be like on the problem set where they're going to ask for surface area? And then so could you do like?
Yes. You just write the answer. That's fine. If you just did the other type of problem, I'm good with that. All right. All right, how about volume of a cone? All right, so a cone is a cylinder, but we put it up at a point. So a cylinder has 2 circles, top and bottom, okay? But the cone now meets at a point. So it's actually a third the volume of what it would have been if it was a full cylinder. All right, so 1/3 area of the base times the height. So we have volume of a cone, 1/3. All right, area of the base. So this time, you guys, what shape is the base? Circle. So I have to do pi r squared. But I'm going to go ahead and plug it in, okay? So pi, and I'm going to plug in the radius, 9 squared. Okay? Times the height. Should I plug in 15? No. All right? It is actually not the height of the cone, or whatever this is. Yeah, cone, all right? So 15 is the slant height. We actually need this height right here. So you could do Pythagorean theorem, but it's been a while probably since you've done a squared plus b squared equals c squared. I think the book gives you most of these, but I want to teach you a little trick because they like to put this on the SAT and the ACT, and it's just faster if you know it. So there's this thing called a 3, 4, 5 triangle. All right, it only works for right triangles, okay? It's Pythagorean theorem because if you do 3 squared is 9 plus 4 squared is 16, you get 25, which equals that. A squared plus b squared equals c squared, okay? If you memorize that a 3, 4, 5 is always a right triangle, you'll be able to quickly find the missing side because all they did was multiply the 3, 4, 5 triangle by what? by 3, right? So this is 3 times 3 is 9. This one is 5 times 3 is 15. So this one would be 4 times 3. So I know the height is actually 12 because it's just a 3, 4, 5 triangle all multiplied by 3. So if you can recognize that, it's just faster than Pythagorean theorem, okay? So my height is actually 12. All right, you have to do the exponent first. Do not divide the 9 by 3. That would mess you up. All right, you can do 1/3, then do 9 squared. This has to go first. So that's 81 pi, all right, and then times 12. All right, we can divide the 3 into the 81 or the 3 into the 12. So let's say I divide the 3 into the 12. That gives me 4. Then I have to do 4 times 81. What is that? Okay. Meters cubed, because it's volume. All right. Oh, did I forget the pi? I lost the pi. Thank you, guys. Oops. And yes, I want you to plug these into your calculator, okay? I'm not going to do it right now, but plug those in on your homework. Yes.
I forgot how you got 12 from that.
Because I did the 3, 4, 5 triangle, or you could do Pythagorean theorem. But this side's 9, this side's 15. So this is the multiple of the 3, 4, 5 by multiplying a 3, 4, 5 all by the same number. So I knew it was 12. Yep. All right, find the surface area of a cone. So the formula, you guys, for surface area of the cone is the same as the formula for surface area of a pyramid. If you memorize this formula, it's the easiest one to memorize, and it will take care of both cones and pyramids. This is one you want to memorize again, okay? I feel like the volume one is easy, 1/3 area of the base times the height. This one's annoying, all right? Same formula that we just did for pyramid, but now we're doing it for cone, okay? So the main difference is if it's a cone, right, it looks like this. The area of the base is going to be what formula? Pi r squared, because it's a circle, okay? And the area, or the perimeter of the base is going to be what formula? Pi d or 2 pi r. I would do 2 pi r because the 2's will cancel. It's nicer. All right, so let's try one. Okay, find the, I actually want to just start with total surface area. All right, let's do this part first. Find the total surface area. All right, so we're going to use the formula. Area of the base plus perimeter of the base times the slant height divided by 2. Okay, area of the base this time is a circle, so I'm going to plug in pi r squared. Okay, go ahead and plug in your 9 for the radius. All right. Now, perimeter of the base, okay, is a circle, and the formula for perimeter is 2 pi r. I'm going to plug in the 9, though, for the radius. All right. Then I multiply by L. What is L in this problem? Yes, we actually have it this time, okay? It's the slant height. You want to use 15 for the slant height, divided by 2. So the biggest thing is remembering that that L means slant height. All right. Now I have 81 pi. All right, my 2's cancel out. Then I have 9 times 15 times pi. What is that, you guys? Yeah, 135 pi. Okay, these do add together because they both have pi's. So that's 216 pi meters squared because it's surface area. And then, yeah, you'll plug it into your calculator. Okay. So you guys, if it asked for now, if there was like a part B on the problem and it asked for the lateral surface area, could you just tell me the answer right off the bat? What is it? Or 135 pi meters squared. It's this piece of the formula, okay? So it's the PBL divided by 2. Whoa. All righty. So there's your lateral surface area. All right, you guys, let's try some problemos.